Geoff, Acceleware makes some very exciting technology to electrify the what now is done by natural gas in the oil sands. Can you describe how your technology works, please?
Yeah, exactly. So similar to how SAGD works, where you inject steam underground to soften bitumen, and then below the injector well, you have another horizontal well that collects the condensed steam and bitumen and brings it to surface. What we do instead of injecting steam is we are essentially injecting electromagnetic energy in the form of radio frequency energy. That heats the oil that's already present in, or the water that's already present in a heavy oil or oil sands reservoir. And that softens, that converts to steam, softens the bitumen, and we produce that. So it's kind of like a subterranean microwave oven, similar to how microwave oven heats water in food. This is how RFXL works, what we call RFXL, which is radio frequency heating for oil sands and heavy oil production.
Is the technology efficient enough to match the kind of efficiencies provided by natural gas making steam?
Right. We actually expect in the average oil sands or heavy oil reservoir, we expect RFXL to be 50 to 60% of the energy use that you would have with SAGD. So we expect it to be much more efficient. Most of that energy efficiency comes from the fact that we're generating the heat where you require it, which is right in the reservoir, rather than generating it at surface, pumping it in long steam pipelines down a vertical well into the horizontal injector. So yeah, we definitely expect it to be more efficient and with reduced operating cost as a result.
Does your technology allow for more precise heating in the reservoir? Because I've seen that raised as an issue for companies that are using steam.
Not exactly, but one of the benefits you do get from radio frequency heating, according to simulations, is that you get quicker initial heating. So oil companies can benefit from having quicker first oil than they would get with SAGD, because with SAGD you need to circulate steam for a while before you have the effect of communication between the heater well and the producer well. With RFXL, we get that sooner. So not necessarily more precise, but sooner oil, and that's definitely a benefit for producers.
What about providing the electricity for the RFXL? How much, like if you were doing a SAGD field, how much electricity would that consume?
Right, so what we're looking at in terms of heavy oil wells, which are slightly less viscous than, say, bitumen oil sands reservoirs, we're thinking 2 megawatts to 4 megawatts per well, and these wells would be similar to a SAGD well. And for oil sands, 4 to 6 megawatts per well.
Now, I can see the oil sands companies saying that's a lot of power.
Right.
We're up in northern Alberta. What options are available to the companies to generate that kind of electricity? Can they use wind, solar, and storage?
Yeah, exactly. I think one of the benefits that you see from RF heating is just like a microwave oven, it's pretty much on-off. So it can operate on intermittent power so long as over, say, a day period or a week period, you can still inject the same energy. So you have periods of intense injection, periods of less intense injection. RFXL can handle that type of intermittence much better than SAGD.
So you've been doing some pilots with a number of oil sands companies. What can you tell us about the pilots?
Right, so we have one pilot going in a heavy oil reservoir just northwest of Lloydminster, Alberta, near the town of Marwayne. And it is approximately 800-meter horizontal multilateral RFXL well and a producer well underneath it. It's about a high 20s, about $30 million pilot, and it's been funded by federal government, provincial government, and 3 oil sands producers. The oil sands producers are interested in it from point of view of not just heavy oil production, but also for bitumen production in oil sands reservoirs. We started up the pilot in March of last year, operated it continuously for about 6 months. We are currently shut down due to maintenance issues. We want to, based on the learnings we've gotten so far, we want to make some improvements, do some repairs, and get back operating here in the next few weeks to months.
Now, you've been working on this for a while. I think I did my first interview with you folks in 2018 or 2019.
Right.
What are the major obstacles to developing and scaling up your technology?
Well, first of all, because our technology is subsurface technology, whenever you deploy something in the subsurface, it's expensive. It requires lengthy regulatory approvals, but also whenever you're dealing in the subsurface, it's uncertain and it's hard and it's quite an R&D endeavor. So our primary, let's say, difficulties are related to money. They always come down to funding and come down to the fact that whenever you're doing something in the subsurface, it's expensive, and it's often more expensive than you think it's going to be. So we are continuously looking for additional funding, sources of capital, people who want to get in on the project, see the benefits of it, and we spend quite a bit of time seeking out that capital, and we try to do that in parallel with the R&D effort, but sometimes we have to slow down the R&D effort to wait for the capital to come in.
Are there any bottlenecks or maybe suggestions for improvements you have to how both the Alberta government and the federal government, and maybe the oil sands companies, ultimately your customers, how they could do this better?
Yeah, I do have some ideas on that. One of the things that the governments do is they look to the oil sands or the industry generally, like we can look at beyond oil and gas here, but they look to industry to provide credibility to the people that are seeking the funding. For example, it's easier to provide funding if you have a oil sands producer saying, we'll also provide some funding alongside you, we'll provide some technical input for these folks that are kind of in a startup mode, and so that you can rest assured that that industry wants this, that industry is involved in this, so when you give your money, there's a pathway for it being deployed. I think that's good in respect to the fact that you end up with significant pull on the technology, but sometimes as these projects start to progress, the objectives of the government and the objectives of the industry might diverge a little bit, and these programs have to be resilient to that divergence down the road. Plus, when you're talking about multi-year projects, there's changes in governments, and there's also changes in leadership at some of these industry companies as well. So the projects have to be able to survive those changes as well.
One of the things we're seeing in the United States as a result of the Inflation Reduction Act and their adoption of a very aggressive clean energy industrial policy is they've streamlined many of the government processes for providing both funding and technical support to get over some of the road bumps, the speed bumps that you're talking about. Do you think that there are opportunities for Canada and Alberta to learn from those experiences and make this process more efficient?
I definitely think that should be there should be lessons learned there. I do believe that Canada, in the sense of clean tech funding, is lagging behind. What just took, isn't it just 1 year plus a couple of months, the anniversary of the Inflation Reduction Act, and already you're seeing capital start to flow. We've had situations where we've had signed agreements with funding agencies and industry, and it takes a year for funding to start to flow even after a signed agreement. So I think one of the things that Canada should learn from that is that speed, like time is of the essence here. We're talking about 2030, we're talking about 2035. These are dates that are fast approaching, and we don't have a year to wait. I think that's the major learning is get money flowing.
For viewers who aren't as familiar with the oil sands are very emissions intense because they burn natural gas to create steam to soften up the bitumen so they can produce it. But your process, as I understand it, would produce zero emissions. And in fact, if it were adopted on a large scale, there would be no need for carbon capture and storage.
That's correct. So instead of abating emissions, we're actually not creating emissions because our technology, we're as clean as the energy source, the electric energy source you hook it up to. And we're resilient to the intermittent or unreliability of many renewables. So like if you can hook this up to solar, wind, hydro, nuclear, we would be completely non-emitting, and we wouldn't have to rely on the technical uncertainties associated with carbon capture and storage. And on top of that, we wouldn't have the possibility of fugitive methane emissions, which, although the industry is working hard on that, it still remains a reality that whenever you use natural gas, you're going to have fugitive emissions.
Is it also the case that your technology lowers operating costs for the company?
That's right. We expect 40 to 50% reduction in operating costs for the company, not just because of the energy savings, but also because of essentially what a SAGD facility looks like is a massive water treatment plant. You are essentially taking water and you're converting it into steam. That condenses downhole. You pump that back to surface. You do recover waste heat from it, but you also have to add additional makeup water. So you're using fresh water. We don't use any fresh water. You have to treat that water. You have to convert it back into steam and then pump it downhole again. So we eliminate all of that activity associated with the water handling part of SAGD. So big chemicals reduction as far as OPEX go, as well as the fuel/energy reductions.
Now, for someone like me, your technology almost sounds like a perfect solution to a problem that's plagued the oil sands industry for a long time. I would think that the oil sands companies would be really, really keen to see this adopted. What kind of feedback are you getting from them?
I think that from the oil sands companies, we have to be clear that SAGD as a process works really well. It definitely is something that provides reliable cash flows for the companies, is a massive technological advancement. And so there's a lot of capital that has been invested in it. There's a lot of people who have grown up with SAGD, and it's been tweaked over time, so it's a very reliable process. So if we have something that comes along that appears to be better, it's going to have to be significantly tested. It's going to have to be reliable in order for oil sands companies to move away from something that works so well. But I think from their point of view, if the answer to SAGD emissions is carbon capture and storage, which has significant technical hurdles, why not just attack the emissions at their source, which is burning natural gas to make steam? So I see a lot of interest from oil sands companies. I see a lot of interest also from heavy oil companies. We see great interest from overseas as well. Middle East has a lot of heavy oil. California, South America, Central America, where they have lots of heavy oil but not a lot of natural gas to make steam. So there's a lot of interest internationally, but I do think there is interest locally in Alberta and Saskatchewan. Just in the local market, we have to generate more pace from these oil sands companies in terms of adopting and supporting new technology.
It sounds like for governments, because both the Alberta and the federal government talk about this, and what I'm referring to is de-risking of new technologies, scaling up of new technologies. This sounds like a case study on where the government should come together with industry and with the vendor, the supplier, the developer of the technology, and work to de-risk this technology quicker, because the benefits could be significant.
Yeah, I think so. I mean, especially when you're talking about something in clean tech or something that specifically is attacking greenhouse gas emissions, the time is of the essence for sure, right? And so it seems to me that that the period of time between, say, initial contract award, whether we're talking about government incentives or industry participation, between that and subsequent rounds of funding should be shorter. It should be a case where you should be able to say, we've had encouraging results, we want to do this now, we want to move to the next level, help us now, rather than going through another round of negotiations or applications for additional funding or more presentations that you have to give to industry to acquire that capital. Once you start down the road, you should be prepared to get to the end of the road in terms of the technology development, even if that costs more than initially expected when the grant was awarded. And this is R&D, so that should be expected, right? That there's a certain amount of uncertainty on what a project's going to cost.
Final question. This is homegrown technology in Alberta. If you are successful and you scale up to take advantage of these opportunities that you were talking about, would the manufacture of the RF XL units be done in Alberta, and most of the supply chain be in Alberta?
Yeah, we've actually learned some significant lessons regarding supply chain and supply chain risk during the whole COVID era, which was when we were acquiring most of the material for our pilot in Marwayne, saying to us, some of these offshore vendors of materials, advanced materials, as well as advanced electronics that go into our technology, we need to have onshore and local suppliers of that technology, or some of those materials and services. So what we've been trying to do is say, okay, maybe some of these raw materials, there are no other vendors except for, say, Asian suppliers or European suppliers, but maybe we can do most of the value added here in Alberta to reduce some of that supply chain risk. So that's totally in our plans to do most of the value add here in Alberta.
Well, it sounds like a great opportunity and really interesting technology, so all the best. Thank you very much for the interview.
Thanks for having me.